Hello everyone, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you have not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. So problem is remove k digits. Very interesting problem. So in this problem we are given a string and that is representing a non-negative integer. So this string is given to us and it's a non-negative integer and an integer k is given. So we need to return the smallest possible integer after removing k digits from num. So from this number, we need to remove k digits. That is 3 digits we need to remove from this number so that smallest integer is created. So see, if from here we remove 4, 3 and 2. So these three numbers because k is 3 na, so we need to remove 3 numbers. So if we remove these 3 numbers, the number we will get will be 1219. So this is the smallest number 1219 which can be created by removing 3 digits. Right. So this is the problem. In the second test case, if you see, here we just need to remove one digit. So if we just remove this one, we will get what? 0200. And this leading 0 has no benefit obviously, so 200 we will get. Remove the leading one. We are removing this one because we can remove one integer. So we are removing this one and 0 because it is leading 0, so that we do not need to have. Output must not contain leading zeros, so that 0 we removed, and then rest of the number 200 which we get. Similarly for this number 10, we have to remove 2 digits, so we will remove these 2 digits and we get like empty string. Then we number becomes empty because we have deleted both the integers. So then we just return 0, right? So this is a problem. See, this is the problem. Now see, when we see this problem for the first time, now what we like quickly think, we think that okay, we can try removing all the digits. Like we have to remove 3 digits na. So what we can do is either we can remove this or this. Like see, let's see over here. So what I thought initially was, what I can do, I have to remove 3 digits na. I have to remove 3 digits. So what I'll do is I can remove this one or this one, or I can remove this or this. Anything I can remove na, any three digits. So that will lead to all combinations will be there na. This could be deleted, so this will be the number left. Or you can do what? You can delete this and this and this, so this will be number left. But see guys, we are not, there is no need to generate all the combinations. In this case na, like if we do like this, so every combination will be generated where we are deleting the three digits and the rest of the 4 digits we'll have. So if I delete these, let's say I delete this 4, I delete this 4, this 2 and this 1. So then the rest of the number will be 1, 3, 2, 9. This will I will get this. But see, there is no need to generate all the numbers. All the combinations, there is no need. Why? Because there is an easy way we can do this entirely. Let's see that. So what after that I thought like maybe there could be another way. There is, if because see, if we do na, if we generate all the combinations, that will be not efficient approach, because see, k could be very large. If you see the constraints, k could be 10 raised to power 5 also. So there will be no benefit of generating all the combinations because that will be very huge. Then recursive calls will be very large. That is not what we need to do over here. We here see what we need to do. We need to find the smallest number na, after removing k digits. From this first test case, Just see this test case again and try to think, if you're able to think of any approach. See, we need to remove three digits, and what we are removing? We are removing 4, 3 and 2. That is these we are removing. These we are removing, and these are largest numbers. See, these are some largest number, 4, 3, 2. So see, here we get 2, here we get 2, and these all numbers are larger or equal to 2. See, 4, 3, 2 are greater than this 2. So see, what we can do is, we what we observed, that when we are here, these all numbers, these three numbers are greater than this 2 or equal. This 2 is equal, right? So what we can do over here is, if we remove these, because these are greater numbers na, and they're coming in the starting, you will say 9 is also a greater number, but see, it's at the end na, it's at the zeroth place. So that is not contributing to making the number largest. These are the at the more significant places na. So if I remove these larger numbers, so what I get? 1 will be as such, 2, 1 and 9. Right, right. So this is the smallest number which I can get. If you say that no, I do not agree, if I want to remove 9 because it's the largest number, I want to remove that. So if you remove this 9, what you will do is, you will remove the largest number, and then the second largest, and then the third largest. So you remove 9, you remove 4, and then you remove 3, because this is the largest, and then this is the second largest, and this is the third largest. So what number you will get then? 1, these will be removed, 2, 2, and this 1. So this is 1219 and this is 1221. So this is smallest na, this is greater than this number. So answer should be this one. That is why it does not depend that which number is the greatest. It depends which number is coming first, which is greater. Like see, 4, 3, 2, these numbers, if they are greater than this number, so if we remove these numbers, then we could have that could be beneficial for us, right? If you see this test case also, I hope you're understanding what I'm trying to like get to here. So let's see this test case also. 1 0 2 0 0, we have this na, we have this, and k is 1. So over here, if you say that remove the largest number, which is 2, so I remove this 2 because I can only remove one digit, so I'm removing this 2. So number which I get will be 1, this 1000, this 2 will be removed, and 1000, this will be the number. But if we start from the starting, we go from here, we go here, then we go here, and we see that we are at 0, but this 1 was greater than 0. This 1 was greater than 0. Similarly, like here na, here it was same case na, that here we were at this 2, and these 4, 3, 2 were greater or equal to this 2. So we remove those. Similarly, here this 1 is greater than this 0. This 1 is greater than this 0, right? So if I remove this 1, I will get this number 0, 2, 0, 0. And we do not require this leading zeros. So this will be the number. So see, if you remove the largest number, then you are getting this number. But if you start from the beginning and compare like this, then you get 200. So this is the smallest number which we need to return. All right. So the approach which we will use here, see guys, it's very important. Approach we will use is, see what we will do. Let's write this test case. So it's 1 4 3 1 4 3 2 2 1 9, right? 1 4 3 2 2 1 9, yeah. And k is 3. So what we will do, we will start from here, we will traverse this string, this is a string, right? This is a string. We will traverse this string, And whenever like we are here, we will check if there are numbers greater than this 2 before it. So for example here, before this 2 we had these numbers na. So if you see for this, see for this 3 also, when we are here, so this 4 is greater than 3, this 4 is greater than 3 na. So we'll remove this 4. Then we go ahead. Now this 3 is greater than this 2, so this 3 will be removed. And then we go here, so these are equal, so we can remove this one. So then we get 1 2 1 9. This approach we will be following. But now how we will do this, how we will check, whether how many numbers are like greater than this. For example, we are here, so we are here, how we will know that this is greater than this? It could be, see, it could be this also na. So yeah, we'll see that test case afterwards. So for this na, for this we will use a stack to know how many numbers are greater than, like this 2, how many numbers are greater than it before it. So see how we will use a stack. How we'll use a stack, let's see that. So see, it bit of complicated, but don't worry, once we are done with the dry run you will better understand. So see, we use a stack. We have the stack. Initially we are here at 1, we just push it because stack is right now empty. So when just stack is empty, stack is right now empty na, empty, so just simply push, nothing to check, just push. So 1 is pushed. Now we come here, we check 4. We have the we have 4, we have 4, and we will check whether this element which is currently at the top of the stack, that is top of the stack, top of stack, is top of the stack greater than the element current. This is the element. No, like 4 is greater than this 1, 1 is not greater than 4. So we can simply push this 4. Then we come here at 3. Now element is 3. Element is 3, right? Now see. Now this top of the stack is what? 4. 4 is greater than this element 3. Means we can remove this 4. Just remove this 4. It's not, because see guys, why we are removing this 4? Because if we do not remove this 4, number will be what? Like 1 4 something, 1 4 something. But if we remove 4 and we add 3 in place of it, then number will be what? 1 3 something. We need to find smallest number na, we need to find smallest number. So that's why when this 4, the top of the stack, is greater than the element, we remove that top. Because if we do not remove it, we get this thing 1 4 and then 3 something like that. But if we remove it, we get 1 3. So this is 13 something and this is 14 something. So obviously this is smaller na. So that's why when the top of stack is greater than the element, we will pop from stack. Pop. So pop, 4 is popped. I hope you're getting. So 3 we will be add. We'll add 3. Right. I hope you're understanding. So let's dive in further. Let's go ahead. So here we get 2. Element is 2. Now again check. Top of stack is what? 3. Is 3 greater than 2? Yes. So 1 could be possibility we get a number 1 3 something. If we do not pop this 3. And if we pop this 3, we get 1 2 something. So obviously this is better na. So that's why we'll pop it. Just pop it. And add 2. So we popping it and we are adding element. We are pushing the element in the stack. Right. So we go ahead. We go ahead and then we get 2. Element is 2 again. So this is element is 2. So see, now these are equal, right? Top of the stack and this is equal. So what we can do is we can remove this. So just remove it and we will get this 2. Or let's do one thing. Let's not remove it. We can keep it like that only. So um, or we okay, we can just remove it. So we remove this 2, right? We remove the 2, and then we go ahead and we get 1. So element is now 1. So top of the stack is 2, which is greater than 1, right? So which is greater than 1. So what we do is over here, yeah, so we see, let's not pop it, we will keep this 2 again. So now we get 1, and this is greater than this, na? So we'll pop it and we'll add 1. So we'll keep this like greater than only. Let's keep the greater than condition because that is going in sync with our dry run, like this. And then what will happen? We get 9. So 9. So top of the stack is 1, which is not greater than 9. So we will add 9 simply. So see, after whole traversal of the string, we get number, which is, if you pop it from the stack, 9 1 2 1. So 1 2 1 9, we get the number, which is the smallest number, right? Don't worry, we'll let's again dry run on another test case. So let's take this one, 1 0 2 0 0, 1 0 2 0 0. All right, now let's make the stack. So the condition was that if top will be greater than the element, we will pop from the stack and we will push the element. Push element will be pushed every time, right? So see, we are here. Currently stack is empty. We will just add 1. Go ahead. Now we have element as 0. 0. Top of the stack is what? 1. 1 is greater than element. So what we will do? We will pop this 1 from the stack and we will add 0. Right? Then we go to the next number. Element is 2 now. 2, top of the stack is 0. And element is 2. So 0 is not greater than 2. Hence 2 we will push in the stack. Then we go ahead. We get 0. So element is 0 now. Element is 0. And top of the stack is 2. So now you might be thinking that now 2 is greater than 0. Means we have to pop this 2. But no, we will not pop. Why? Because see, k was what? K was 1, na? K was 1 given. So k is 1. So that's why we have already removed this 1, na? We already removed this 1 digit. So now we will not remove anything. So k is now 0. So we will not remove anything and we'll just push these numbers in the stack like this. So then what we will do, we will pop the from the stack. So 0 2 0 0 we get, and we'll check whether there is a leading 0. If there is a leading 0, we'll remove it. This is a leading 0, we'll remove it, and this will be the output. This will be the output. So every time when you are popping from the stack, when you're popping from the stack, here one thing you need to do. We saw that. We just saw that if we do not decrement k, we will be again popping unnecessarily. But we have to only pop k elements, na? So whenever you are popping from the stack, you have to decrement k also. So here we have to do pop and decrement k because you have removed one element. So this is one test case. See, we are thinking and we are improving an algorithm, right? Now let's see one more test case. So let's do one thing. Let's take this test case, right? Let's take this test case. So let's do one thing. Now let's take this test case and see one more thing which we have to improve in our algorithm. So here k is 9, means we need to remove 9 digits, right? Let's take a stack, and condition was that if top of the element is greater, top of the stack is greater than the element, we will pop from the stack and we will decrement k. And push, so we are every time doing, right? Push the element. So see, what we do first, we start from here. Currently stack is empty, so when stack is empty we just simply push in the stack. 1 is pushed. We go ahead. Now we get 2. Element is what? 2. What is top of the stack? 1. Is 1 greater than 2? No. So just push in the stack. Similarly, we go ahead. Element is what? 3. Top of the stack is what? 2. Is 2 greater than 3? No. So just push 3 in the stack. Similarly, we go ahead. So here element is what? Element is 4. And top of the stack is what? 3. So 3 greater than 4? No. So this will not, these steps will not do, and we just simply push. So 4 is pushed. Similarly, it goes ahead. We go to 5. Element is 5. Top of the stack is 4. Is 4 greater than 5? No. So just push 5 in the stack. Then we get to 6. Element is what? Element is 6. Top of the stack is what? 5. 5 greater than 6? No. So just push in the stack. 6 is pushed in the stack, so there is no space. 6. We go ahead. Similarly, see, same steps. Now 7 is there. 6 is the top of the stack. 7 not greater, just push 7. Similarly, we push 8 and we push 8, and then now we go ahead and we get element as 9. Top of the stack is 8. 8 not greater than 9, so we'll push 9 also. Now see, now we go to 0. We go to 0. So now top of the stack is what? 9, and the element is what? 0. So element is here 0. Element is 0, right? This is true. So we will pop. But now the question is, how many times we will pop? Will there be if here, or will there be while? So that means like until this loop will continue until top is greater than the element. That way we will do, or will we do just this only once? Like we will have if only, like once. So see guys, from this test case we can see that we will be using while, because here we will be popping, we will be keep on popping until there are no greater elements before this 0. So right now 9 is greater than 0, this condition is true, so we will be using while here, right? Just like I've taken this test case so that you can understand why we are using while, not if. So this condition is true, 9 is greater than 0, we will pop 9. 9 is popped. 9 is popped and k we will decrease. So k we will decrease. It will be 8. Similarly, now top is what? This again, while loop will again it will go. It will again check the condition. Top is what? 8. 8 is greater than 0. Again, this will get removed. And k will decrease. So see, this will keep on happening. Now top will be 7. And 7 is greater than 0. So what will happen is, until k is not equal to 0, until k is not, here we will write k is not equal to 0, just keep on popping until we have this top greater than the current element. So what will happen? 6 will get removed, 5 will be removed, 4, because 4 is greater than 0, then 3 is greater than 0, 2 is greater than 0, 1 is greater than 0. Now we got stack empty, so now we cannot pop anything, and also this will reduce, k will be equal to 0. Whenever we are popping, we are decrementing also, na k. So here also one condition, until stack, there is something in the stack, because then only you will be able to pop na. So if stack is not empty, that condition also you need to add. And at last we will push this 0 in the stack. So now this is only the number left, so 0 will be the output for this test case. Because what we are doing, we are removing 9 integers, all these 9 digits will be removed, and the rest number, which will be the smallest number left, will be 0. So guys, I hope you understood from these test cases. We discussed 3 test cases. Now let's see the code. So before that, yeah, let's see the code. So see, what we are doing is, we are just like, this is a edge case, that if the size of the string is less than the digits we have to remove, then obviously answer will be 0. Because for example, let's say we have this, we have 1 2 3, but k is given to be 5, that we have to remove 5 digits, but the string is only of 3 digits, so how we will remove 5 na? So then answer will be 0. 0. All right. And then what we can do is, we'll be having this for loop. In this, what we are doing is, if you remember what we were doing, we were going to each digit in the string, going to each digit, and if the stack was empty, we just simply push. So when the stack was empty, we just simply push the first element, and after that we have this while loop here, that if stack is not empty and the top is greater than the current element, if the top is greater than the current element and k is not 0, that is k is greater than 0, pop from the stack and decrement k. This is the while loop, right? This is the while loop. And this, every time we are pushing in the stack whatever the element was, so that we were pushing, if you remember. These are same steps which we did. So right after this, what we were doing was, we were checking, we were just popping from the stack. So see, we are popping like this. We are not doing this answer plus is equal to whatever s top is. Why we are not doing this thing? Because we need to like, if you remember here, we have to have elements in the correct order na? So if you generally remove from the stack, 0 will be there, 0 0 2 0, this will be the number. But we don't want this now, we want it in the correct order. So that's why whatever we are popping, we are inserting it in the beginning. That is, we pop 0, then we pop this 0, so this will not come here, it will come here, 0. Then we pop this 2, so 2 will not come at the end, it will come in the beginning, and then this 0. So like this. So this we are doing that, and this answer string is the string which we are making. And after that, if there are any leading zeros, there are leading zeros. So here leading 0 was there na, so we were removing it. We removed this leading 0. All right, we removed this leading 0. We taken this I pointer until there is 0 in the starting. Just move on, keep on incrementing I, and at the end, if your answer is empty, so just return 0. Otherwise, return substring from that. So like over here, I will start from 0, but here 0 is there, so I will go to this one, and now there is no 0. So what we will take, substring, we will take string substring from this I index, from this. So 200 will be the answer. All right. So guys, this is simple, very simple approach, right? One thing which we left was, is this thing. Let's discuss a test case for that, because it's very important to understand that case. So let's see that. Let's take an example. Let's take, we have 1 4 3 2 0, no, not 0, 7 8, and k is 4. We have this thing, right? Now see, let's dry run our algorithm. So I hope, just do one thing first, pause this video and try to dry run by yourself, and then see what is happening in this case. Right, so what we will do is, we will have 1 first of all in the stack, then we go ahead, and what was the condition? Top should be greater than the element, and if it is that, then we pop and we decrement k. So now element is 4, so top is 1, which is not greater than 4, so 4 will be pushed. Then we go ahead, we get element as 3. Now top is what? 4, and 4 is greater than 3, so we'll pop it from the stack. So we will do this. All right, now 3 will be pushed. We go ahead, element is 2, top is 3, 3 is greater than 2, decrement k, and pop from the stack. So 3 is popped from the stack. And we get 2. We get 2. Then we go ahead. Element is what? 7. Element is 7. See this guys, it's very interesting test case. Element is 7. And 7 is greater than, sorry, top is 2 and 2 is greater than element is with 7. No, this is not the case. So what will happen? 7 will just push in the stack, and 8, then element is 8, top is 7. 7 is not greater than 8, so 8 will also get pushed in the stack. Now see guys, this for loop is completed. This for loop is completed. But still k is not reduced to 0. We haven't removed all the digits. We have to remove k digits. We have only removed 2, which are 4 and 3. We have still k left. Still we have k left, right? So now what we will do? See, now while k is greater than 0, k is greater than 0, we will remove the largest elements. So that what our strategy is to remove the largest. So right now number is 1, 2, 7, 8. This is the number. So guys, what do you think? What will be the what will be beneficial if we remove these or we will remove these? Last na. So what we will do, once we are completed with the for loop and we are outside and still k is greater than 0, we will keep on popping from the stack. 8 we will remove. So 1, k is reduced by 1. Still k is not greater than is not 0, it's greater than 0. So again we will pop from the stack 7, and then it will go 0. So see, now our number is what? 1, 2. So then we will just store it in answer string, and then we will check for the leading zeros, and then we will return it. So answer will be 12 for this test case. So 1, 4, 3, 2, 7, 8. If you check here, let's take this test case 1, 4, 3, 2, 7, 8. This is the test case now. 1, 4, 3, 2, 7, 8, and k was 4. So if you run this, we'll get 12 as the answer. So we get 12 here. Alright. So here I just remove this. I have written this. We get 12. Right. So if you submit this, this is getting accepted. So guys, I hope you understood the problem and the approach. Very interesting problem it was. Let me know in the comments if you have any doubt. If you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video.